beautiful day, successful day that we are doing this unit 1 atomic structure. It's really successful. I guess you guys understood this hydrogen spectrum really nicely last week. Still, I want to go through that. Maybe you would feel bored, like if you understood everything really nicely, you would feel bored, but still I'm going to go through the hydrogen spectrum because out of unit 1, this is sort of a little frustrating for some kids. Okay, tell me, what are these 5 series of hydrogen spectrum? Balmer, Lyman, Paschen, Brackett and Fun series. Okay, so they found out the Balmer series very first. The reason is those are colors. So you can see these colors clearly. So that they first found out this Balmer series, and there were 4 different colors. Those are red, green, blue and violet. You guys know the red having the least energy, violet having the highest energy. So that least energy is supposed to start from the side. You have this nucleus, so the nucleus is somewhere here. So that away from the nucleus, it simply means that the energy, these spectral lines are increasing. At the same time, they observed that these lines are getting closer away from the nucleus. So using that spectral lines, they predicted these energy levels of this hydrogen atom. So that, see, you guys again can see, this is the nucleus side. Getting away from the nucleus, energy is increasing, and also this energy gap is little by little decreasing. But not only this one, later, after a particular time, when they done some other experiment, they found there is another, this is one set, there is another set having higher energy and some other series which are having lower energies like this. So that then they understood this is supposed to be the closest, the electronic transitions coming from higher energy level to the closest energy level to the nucleus. So that then they decided this is supposed to be the energy level which n equals to 1. And then this one, the one we already saw these 4 different colors, and this n supposed to be n equals to 2. Then this one n equals to 3, n equals to 4, n equals to 5, and so on. Different energy levels are there. Come down. I'm started already. So that this is what happened on screen. These are the spectral line. This is happening on this inside this hydrogen atom. Okay, so that once we found out all the other series, we could build up this one. This is a real hydrogen spectrum. We did this one not last week, day before that week, I guess. Yeah, now this is the 3rd week I'm doing the hydrogen spectrum. You guys supposed to feel really comfortable now. Okay, so that these are the electronic transitions happens inside the atom, going from any, like this is the emission spectrum. So from high energy level to the lowest energy levels, n equals to 1 fall onto UV region, 2 visible, then Paschen bracket fun, 3, 4, 5 fall into IR region. Okay, so that from here to here to the direction, these lines are getting closer. See, each of these region lines are getting closer towards this direction. So simply mean from here to here, energy is increasing, frequency increasing, and also wavelength is decreasing. And the opposite of this is the with respect to wavelength. So that wavelength goes to the other direction. To the direction energy is increasing, wavelength is supposed to be decreasing. So this has the highest energy, least wavelength. This has the least energy with highest wavelength. Okay, so that to understand that, then I was given you guys this next set of question. This we did at the class. Considering first 4 energy transitions of Lyman and Balmer series, draw corresponding spectrum for hydrogen. Okay, so that this is the corresponding spectrum that I'm expecting you guys supposed to draw. So this is the Lyman series transitions coming to n equals to 1, and this is the Balmer series transition coming n equals to 2. So that you have to draw both these electron transitions, and relevant to these 2 transitions, you are drawing these spectral lines. And this part, see, you guys can see this length is greater. So this is the high energy line, that is the Lyman, and this one is smaller. I mean, not wider, narrower comparing to this one. So this is the less energy one. So this is the Balmer series. And energy from here to here energy gap, we can get using either using this gap, either using the difference between these two lines. This is beta gamma, or either using these two lines, that is alpha beta. Last week we did a question to explain you guys. This is whatever these differences gives the exact energy difference between third and fourth energy levels. I guess okay there. How would you get this energy energy difference between energy levels? If you want to get this E3 E4 gap, you can get that using these two lines. Those are, see, beta gamma level, or here again these two lines. That is in between alpha and beta. Is this clear? Come darling. කතා කරන්න ඕනේද? මේ පස්සේ කතා කරමු. ආයෙ පැත්තේ නේ 6 class එක. Okay, did you guys draw this? Exactly this way. Okay. Let me come to check you, otherwise just copy this one. Question number, this is the answer for question number 30. Q30, answer for Q30. Okay, just show everything because we're going to write this again. So XYZ. So what can you say about, just hang in. Let me show you that as well. If you go with XYZ, see, the energy of X is the greatest, then Y, the gap of Z is the smallest. So X is greater than Y, then Z. That's for Balmer series. It's same for Lyman series, C, B and A. C, B and A. C is the greatest, A is the smallest. And then again, this energy gap. See, this energy gap is this. This energy gap is this. And this energy gap is this. Anyway, it's equal to the energy gap between E4 and E3. So you're going to write everything later, but now I want you guys to draw this one. And then see the energy gap. If you go with E3 minus E2 minus E1 is this one. And then E3 minus E2 is this one. The energy is getting smaller. And then E3 minus E2 is this one. See, energy is also getting getting away from the nucleus. Energy is also decreasing. Okay, so we're going to write that later. But I want you guys to just copy down everything here to make sure what you're writing is you can understand. I'm coming to you. If you have any questions, you guys can ask me. Anything? Name line number. You want to do it again? Or you did it this way, don't you? Spectral line. What is the connection between these two? You see? Yeah. Otherwise, we can show the connection. Let's say this. Here you are saying here, so show the connection. Those two have to. Because that is the main part, spectral lines. See? May you go up and what tell me? And then these four you can show here. Don't worry, you have time because Amma drawing everything from the beginning. You have enough time. convinced you guys. So whatever the question they are giving you guys, now you know how to answer. Can I move on? Okay, so see. Distance between lines get decreased towards n equals to alpha. What's the meaning of that? See, when you are getting from here to here, from n equals to 1 to n equals to alpha, see the lines are getting closer to each other. Therefore, energy difference decreases gradually and final tends to be 0. See, this energy gap is also decreasing. At the end of the day, these lines are overlapping with each other. Simply mean when it is closer to, when it is at this infinity, simply mean, so these lines are overlapping to each other. There is no energy gap. So you cannot have these electronic transitions after this level. Clear that? So what is this level? This is the boundary of the atom. Beyond this, what is it? This is the environment, something else. So atom ends here. So that the connection between, let's say the nucleus is here. If the nucleus is here, from nucleus, this is the last level that nucleus can has its this attraction towards the electron. Beyond this level, when the electron is getting away from this one, there is no connection between nucleus and electron. So that we say energy difference decreases gradually and finally tends to become 0. At this point, electron is totally free from influence of the nucleus. That is when the atom is converted to what? Ion. Which ion is that? Negative or positive? Cation. Yeah. Once you remove electrons, you are becoming a cation. If we can calculate the highest frequency of the Riemann series, this energy is corresponding to what? Ionization energy of atom, because this is the lowest energy level, the ground state, and let's say this is the boundary. Okay, beyond boundary, it is making cation. Let's say if this is the highest energy, we can calculate what is that. If you give energy above that, this connection is breaking, so electron is going to the environment. So this highest energy is supposed to be the ionization energy of and this is the ionization energy of hydrogen atom. Understood? Okay, so let's read this part. Uttavi, you missed a little part. Go through the recording to get that. Okay? Okay, let's read this little part. Distance between lines distance between lines get decreased towards n equals to infinity. Therefore, energy difference decreases gradually and finally tends to become 0. At this point, electron is totally free from influence of the nucleus. That is, when the atom is converted to an ion. Therefore, if we can calculate the highest frequency of the Riemann series, this energy is correspond to the ionization energy of hydrogen atom. Clear? Okay, complete this part. Yeah, you can read this, understand this, and then you can complete your note. What is this page number? 45. 45. again for you. You can look at your note. Distance between lines get decreased towards n equals to infinity. Therefore, energy difference decreases gradually and finally tends to become zero. At this point, energy is totally free from influence of the nucleus. That is when the atom is converted to an ion. Therefore, if we can calculate the highest frequency of the line 1 series, this energies correspond to the ionization energy of hydrogen atom. Okay, that's done. Then we talk about the dual nature of the matter. I saw a couple of your notes are having like you are first writing something else, and when looking at the screen you are writing something else. Don't do that because you have made your note really neat and nice. So whenever you feel like you cannot write things, just leave it blank. When you are looking at the screen, then you can fill everything correctly. Okay, so the dual nature means simultaneously at the same time you have particle and wave nature. Example for particle nature is momentum. Example for wave nature is diffraction pattern and interferences. And to understand this particle energy, we are going with Einstein equation E equals mc squared, and this wave energy Planck equation E equals h over lambda. Using these two, we're going to derive this equation lambda equals h over mc. මම මේකේ question එකක් කරන්න හිතෙනවා. හා එන්න questions ගන්න හොඳ වෙලාවට. කරමුද? ඔයගලගේ last page එක බලන්න මොකද තියෙන්නේ කියලා. Yeah. That's question number 21. Go to the last page. Page number 97. Page number 97. Question number 21. Shall we do this? Are you guys there? Let's read the question together. Find out de Broglie wavelength for an electron moving at the speed of 5 into 10 to the power 6 meters per second. Mass of an electron is 9.1 into 10 to the power minus 28 grams, and Planck's constant is 6.63 into 10 to the power minus 34 joule second. Okay. Use a pencil. Get the answer. Use the pencil. Do this question. Q21. Page 95. Page 95, last page. So the question, this equation we did earlier, equation is in the page number, we did it the last day. It is in page number what? Page number, magi සරකින් හරියන්නේ නැහැ. ඔයාලගේ note එකේ බලන්න. Yeah, equation is in page number 46. joule equals to Newton meter, then to cancel off kilogram, you have to convert this joule to kilogram meter per second square. I guess you guys done that for physics. Have you guys done that for physics? Otherwise you can do this. Because I do this for unit 3. Simplification is difficult, otherwise getting answer is easy. Let me show you over here. Simplification is difficult. And here I'm showing this unit problem, unit thingy. Good, good. Physics units on your life, I will tell and when we. Anybody else? What is the answer? 1.4 into the power? Yeah, very good. See? See guys, this class, 10 students. Impressive. Last final answer. Last final answer? Find out the de Broglie wavelength for an electron moving at the speed of 5 into 10 power 6 meters per second. Mass of an electron and Planck's constant is given. So we know the de Broglie equation very easily. You can write the equation, we did it last week, lambda equals h over mc. This is the de Broglie equation. And then just do the substitution. Lambda equals h is 6.63 into 10 power minus 3 joules second. I'm just going with this given data. And then the mass of electron is 9.1 into 10 power minus 28. And then speed is, velocity is 5 into 10 power 6 meters per second. But then the problem is our unit lambda is supposed to come with meters. If you just come here, you can go with like even this per second, you cannot cancel off. If this per second gets to the top, that becomes second. So definitely we have to simplify this joule. Joule equals Newton meter, and then the Newton is kilogram meter per second square, and then that part, if we multiply with this meter here, and then the joule equals kilogram meter to the power 2, second to the power minus 2. Anyway, I'm going to just, instead of this joule, so that I'm just writing Newton meter here, so that Newton equals this. So this is the Newton part. And then meter is this meter. That is, then the second is this second. Second here, that second here, that second is here. Down there, since you have this top kilogram, then I want to simplify this gram to kilogram. If I use another color. Since this is in kilogram, I'm going to convert this gram to kilogram, multiplying with 10 to the power minus 3. Multiplying with 10 to the power minus 3. So that I have this kilogram here, and again this down here meter, and then this per second, kilogram meter per second. Then if you simplify this, kilogram cancelling off, meter cancelling off, now you have this per second, one of the per second and this second is cancelling off. One of this per second is cancelling off to this one, the other one cancelling off to this one. So only remaining unit is meter. So meter and lambda. So the lambda is the length. So the unit meter is acceptable. So we are now in the right path. Okay, we are now in the right path. Okay, so that this part I'm just writing as it is. And then this is I'm just writing as it is. But then to convert this gram to kilogram, I have converted gram to kilogram. So I'm multiplying this by 10 to the power minus 3. But this part I'm not doing anything. This part I'm just writing as it is. Meters per second. And then simplify. Then you have minus 34 here. And you have plus values here minus 28. And here you have minus 28 and minus 3, 31. Minus 6 is 25. So that plus 25. Plus 25. If you simplify these two, you're going to get this 10 to the power minus 9, but then this is 10 to the power minus 9, but then I'm going to go with this scientific notation. Then since I'm moving my decimal from here to here, this is become 10 to the power minus 10. Are you guys okay here? I'm coming to you guys again. If you have any issue, just talk to me. If you feel like something is uneasy, talk to me. If I show you guys this again, maybe you guys went wrong with units. Otherwise, almost all of you were just taken this correct. But couple of you impressively got an exact answer. So you guys are doing good with physics. This Newton, same Newton, this Newton, that is this part, kilogram meter per second square. Then meter second is this meter second. Okay, I'm coming to you. Just ask me if you have any question. Anything? No, I can get down there. Forward. I know there's a one set of students, they have talents, but they are sort of little like bored to do these simplifications. But if you are not doing simplifications, for structured essays, say okay, you can get some marks, but for MCQs, you are not gaining anything. MCQ is at the end of the day final answer. If you are not simplifying everything to until the final answer, you are not gaining marks then. Remember that. So until you get your final answer, you guys have to simplify. Can I move on, everyone? Moving on. Can we finish? Okay. Then we talked about the atomic orbitals. S, symmetrically spherical. P, symmetrically dumbbell. Getting away from the nucleus, size is increasing. Remember, for one single S sub-energy level, you have one single S orbital. That's because there are no symmetry. S has one single symmetry. So whenever there is a F sub-energy level, only one single orbital is there. But if you are moving to p orbitals, there are 3 different p orbitals. So that in one single sub-energy level, there are supposed to be 3 p orbitals, px, py, and pz. How many d orbitals? 5. There are 5 d orbitals. How many f orbitals? 7. We didn't do that, but there are 7. 1s, 3p, 5d, and 7f orbitals. Okay. I'm gonna, quantization of energy. Energy existing as packets is the quantization of energy. To calculate the energy per one single photon, one single quantum, we are using Planck equation E equals h nu. So we are always using this E equals h nu or E equals hc over lambda. Knowing either frequency or either wavelength, we can calculate energy per one single photon. If you multiply this by number of photons, then we can get the total energy. So that I have given this question to convince you guys that a lamp produces 6 joules energy per second. Just forget that part. In a blue region, even I don't want that, but I need that because to make sure that it is in the visible region. But you guys already know, even if they don't say this is in blue region, you guys know what is the nanometer, this range for visible light. Okay, go there. What is the page number? I want to answer. Where is your electromagnetic spectrum? Go there and give me what is this exact value. Don't write anything, I'll give time. Just hang in, I'll give time. Once I explain, you can write. What's the page number? 31. Page number 31. Give me the range of the visible region. 422, 800 or 700. Here it. 750. 750. It is there. Then 407 supposed to fall into which region? Visible region. You guys know that. They were given evidences blue, then and also they say it's visible region. If they were not given both these parts, then still you guys know 470 minutes supposed to be in this visible region. Okay, knowing that, knowing that the what is this 470 nanometer means? What do you measure by nanometers? Wavelength. Understood? So they are talking about the wavelength here. Then we know lambda equals 470. Okay, then my question is, what is the energy per photon of a wavelength is 470. 470. So the lambda equals 470 nanometers. Then they are asking the energy. Then how would you calculate that? E equals, focus. E equals h nu. But we cannot go with frequency because they were not given the frequency, which equals to hc over lambda. And then c is the speed of light, lambda given as a data, h is the Planck constant, so we can calculate the energy per one single photon very easily. We can do that. See, I'm breaking this question into different parts so that we can calculate energy per photon on using this part. So that part I'm calculating here, E equals hc over lambda. Then you substitute h, the Planck's constant, and then the velocity of light, and then the wavelength. But still, this value it comes in meters. නේද? Units පොද දෙනවද ඔයගොල්ලන්ට? Units පොද දෙන එක දැන් ඉඳලා ඔයගොල්ලෝ, if you guys know, units are torturing you guys. That's good because then you guys focus more to this physics unit, that part, and also we're going to do this under unit 3, my third unit, chemical calculation. Until that you have to get support from physics. Until that we are not, the chemistry doesn't support you that much. Anyway, since again you have meter here, and then this is nanometer, make a nanometer name, then you have to convert this back to meter again, multiply with 10 power minus 9, so that this is 470 into 10 power minus 9 meters. So that meter cancelling off, second per second cancelling off, joule, we need energy. Unit of energy is joule, so that we are in the right path. Knowing that, I can simplify these other values. Other values I can simplify. Okay, on the main part here, and this 3 I'm writing here, and 470 I'm writing here. Then I'm going to go separately with powers. 10 to the power minus 34, 10 to the power plus 8, 10 to the power minus 9, going up become 10 to the power plus 9. So if you simplify these powers, the value is minus 17. And if you simplify these numerical value, that is the 6 into 3, 19.89 divided by 470, that value will come this. And then the power is here, 10 to the power minus 17. Or you can go with that value. You can directly go with this one. Or if you simplify, you can get as 4.23 into 10 to the power minus 19. Anyway, what is this value? This is the value of energy of one single photon. One single photon energy on a particle. And then I'm going to go back to the question again. Now we know energy per photon. We don't want this part. Now we know energy of a photon. If energy per photon is this, and they ask, how long should the lamp be lit? How long to generate this kind of photons, this number of photons? Per photon energy, we know that. Per photon energy multiply with total number of photons. Whole gediyaka mila, whole gedi ganen වැඩි කරොත් අපිට මුළු මිල එනවා නේද? Likewise, per photon energy multiplying with number of photon to get total energy. Okay, so I'm going to find out that now. So that per photon energy is this part. And then I'm going to multiply that with the total number of photons, that is 1 into 10 power 20, 1 into 10 power 20, so that I can get the total energy. So that the total energy is this one. If I simplify this further, so the 10 to the power minus 17, 10 to the power minus 20, plus minus 10 to the power 3, and this part again, then, but if you simplify this one, that 1 decimal, 2 decimal, or with the 10 to the power minus 3, see, 1, 1, 2, and 3. So that this is cancelling off. It's like you are multiplying with 1000. value here is 42.3 joules. What is this 42.3? This is the total energy. This is the total energy. Total energy is 43.2. දැන් ආයෙත් ඇවිල්ලා ක්වෙස්චන් එකට බලන්න. එකක් නෙවෙයි අහලා තියෙන්නේ. ඉවරයක් නෑ නේද? දිග ක්වෙස්චන් එකක් කියලා බැන බැන හරි කරන්න ඕනි. Real exam questions. You cannot careless. If the total energy is කීයද අපිට 42.3. Now I can write if the total energy total is 42.3 joules, and then I'm going back to the very first sentence. A lamp produces 6 joules of energy per second. Clear that? Okay. So to lit the lamp for 1 single second, how much energy it's consuming? 6 joules. Then to find out how much the time is, what do we supposed to do? We have to divide the total energy by the per second energy. Clear that? So the total energy is 42.3 joule. Per second energy is 6.6 joule per second. Joules to joule cancelling off. Per second comes to the top, becomes second. So that is the answer. Are you guys okay there? Raise your hand if still confusing. මේක හදාන්න පිස්සු නැටුව නේද last week එකේ. අදපු අයත් හිටියා. මේක ඉස්සලම හැදේ කවුද? ඔයාලගේ? කවුද හැදේ? ටැග් ගත්තේ කවුද? අත උස? මට මතක නැහැ ඒකයි. කොල්ලෝ ටික මම බැලුවා මේ ගර්ල් කෙනෙක්ද වෙන්නන්නේ කියලා නෑ බෝයි කෙනෙක්ව වෙන්නන්නේ. Yeah, good. Okay, so make sure that you guys are improving. ආයෙ දෙන්න බෑ. හරිද? අර කලින් අත්වලට දෙන්නත් බෑ. ආයෙ අලුත් අය. Okay, do you guys want a second explanation here again? Anybody? Really clear? Okay, copy this everything nicely. Roberta, I did. Did it? Good, good. I want you guys to write all the steps. This is real final exam question, so don't miss anything. And you know yesterday, ඔයගොල්ලන් paper class ආපු නැතේ? Raise your hand. අද බනින්නත් බෑ. අද කට්ටිය අඩුයිනේ. අද දවසනේ බනින්න ඕනි කට්ටිය වැඩි දවසක බනින්න ඕනි. I'm suspending my blame today. Paper class ආපු නැතේ අද. හංසජ අයියාව නැතේ. පුතා අයියාව නැතේ. ඇහුන්නේ. So I think අර 27 අයිලා කරලා දැන් එන ලොකුයිනේ එන big කට්ටියනේ දැන්. නිකන් විභාගේ පාස් වගේ ඉන්නේ. මේද? පස්සේ මම ඔයගලන්ට instant exam එකක් තිබ්බා. ඔයගලන්ට තියෙනවා time to time. ඒ එක exam එකක් තිබුණා මම ඔයගලන්ට දුන්නා 2012 paper එක ලියන්න. Can you guys believe that? Like some reached like 34 35 marks. It's a very big huge mark. ඒගොල්ලෝ අපිට organic විතරනේ ඉවර full paper එක ඉවර නැහැනේ. අර දුන්නා කරන්න කියලා. 27 set එක. මම හැදෙන්න ඕන ඔයාලා. එතන ඉන්න super talents ඉන්න අගලක් කළා. ඔයාලත් එහෙමයි but ඔයාලා හැදෙන්න ඕනේ. ඔයගොල්ලෝ තාම too fresh නේ. ඔයගොල්ලන්ව judge කරන්න බැරි තරමට ඔයගොල්ලෝ තාම fresh. Method, done writing. Is it okay to move up here? Are you guys done up here writing? No. Here? Yes? Here? Okay, raise your hand otherwise. හැබැයි අලුතෙන් ආපු සෙට් එකක් තමයි. දිගටම මාත් එක්ක හිටියයි නෙවෙයි. MCQ 50ක පේපර් එකක් දීලා ළමයි 4 දෙනෙක් හිටියා. ඒගොල්ලන්ගේ ලකුණු 20ටත් වැඩි අඩුයි. ඔයාලට එහෙම වෙයිද? ඒ දුන්නේ first 5 units වලින්, baby units වලින්. අර deep units වලින් නෙවෙයි. ලකුණු අඩුවෙන් හම් වෙන easy units වලින්. highest හිටියා 44. නෑ 45 highest හිටියා. අඩුම හිටියා 15. එකම ක්ලාස් එකේනේ. එහෙම වෙන්න දෙන්න එපා. මේක වැටෙන්නේ එක දවසින් නෙවෙයි නේද වැටෙන්නේ. ටික ටික වැටෙන්නේ. Can I move up here? මේ voice එක ඔක්කොම ලියලා ඉවරද? මේවා ලියුවද? හරි. යමු අද challenge එකට. Okay. Moving on. Last little thingy, this little thingy, I explained this one. See, so that even it's 1 photon or 2 photon, 1 photon is h nu, 2 photon will multiply 2, 3 photon will multiply 3, then 10 photon will multiply 10, 10 the power 10 photon is multiplied 10 to the power 10 or 10 to the power 20 multiplied 10 to the power 20. That's what we did today. Today we multiplied by 10 to the power 20. Let's read this little thingy. According to Planck's theory, energy absorption or emission occurs as a photon or multiplicity of it as h nu, 2h nu, 3h nu, etc. Okay, fill this part. Are there spaces here? Fill it. Okay, so the first challenge is done, and then we are moving to the second challenge. I told you guys there are two challenges in unit 1. First one is the hydrogen spectrum, second one is the quantum numbers. Are you guys really okay with hydrogen spectrum? Okay, somebody confidence here set එක. නේද? Okay. Hydrogen spectrum මට මාර විදිහට දැන් හොඳටම ඔළුවට ගිහිල්ලා තියෙන්නේ, and then each time when you done a little part you can go through the tune book and make sure that your knowledge is there. If you could be able to do those deeper, really complex, real final exam questions of the tune book, it simply means your knowledge is there. ඔයගොල්ලන්ගේ knowledge එක perfect කියලා check කරන්න you can go to other two subjects as well. Please, you can do the phase through. Once you've done the little part, if you go to the phase through and check that part, if you feel like you can do this question, then you have the perfect theory knowledge. Any question writing? Still writing. Finished? Okay, listen there. Okay, so the first challenge is done. Then we are moving to the quantum numbers. Quantum number is the exact position of the electron. Olden days, they didn't know like all those sophisticated. Today we have like even to detect the speed of electron, we have these high-speed cameras. You can do that. But olden days they didn't have that. They had only their like the brain power. They have done calculation method to find the exact position of electron. Whenever they are doing this calculation, they came across with 4 different sort of the same kind of digits. At the end of the day, then they found those 4 digits are deciding the exact position of the electron. As an example, even this one I guess I've explained a little last week, I guess, before that. Anyway, so address එක කියන්න පාන්න මේ grand එකේ නේද? මම දන්නේ නැහැ. මොකද නම් දෙකක් තියෙනවා. I don't know that. Anyway, the grand තියෙනවා මෙතන නේද? Okay, this is the grand. ඔන්න අපි දැන් මේ වෙලාවේ ඉන්නේ the grand. අපි ඉන්නවා the grand එකේ. the grand එකේ තියෙන city එක කියන්නේ. අපි ඉන්නවනේ රත්නපුර කියන city එකේ. රත්නපුර city එකේ අයිති what is the country? That is Sri Lanka. නේද? ශ්‍රී ලංකාව එක කොහෙද තියෙන්නේ? මේ අපේ වර්ල්ඩ් එකේ නේද? තව intergalaxy spaces and some other තියෙනවා නේද? එහෙම කතන්දර පිටමුකෝ. ඔන්නෝම තියෙනවා. Okay. So that let's say this is the main energy level. Let's say this is the main energy level, the biggest one. Main energy level subdivided into what? Sub energy level. Okay, I'm going to go with, let's say this is the Sri Lanka. This is Sri Lanka. That's subdivided into cities. Cities are then sub energy level. Main energy level divided into sub energy level. Sub energy level divided into what? Somebody. Orbiters. Well done. Orbiters. So these are orbiters. And each of these orbiters are having two electrons. The last quantum number we are talking here is the spin quantum number. It's talking about the spinning of the one single electron. So same as, let's say, Sri Lanka, Ratnapura, and then the Grand. So whatever the postal address, whoever sent, නේද මට ලස්සන ඔයගලන්ට gifts එකක් මම address එක දුන්නේ. එව්වොත් කොහෙද දෙන්නේ? Throughout the whole world, it is in one single place. Same way, if you define these four quantum numbers to any electron, that is a one single electron. Simply mean දෙන්නෙක්ට දෙතැනක දෙන්නෙක්ට you cannot exist one single address. Same way, for two electrons, you can have one single four quantum numbers. Four quantum numbers are always characteristic only for one single electron. Okay, so those four quantum numbers are these four. They have different names here. Principal, azimuthal, magnetic spin. I don't know what is the meaning of this azimuthal, seriously. මේකේ සිංහල එක දන්නේ නැහැ. උද්දිකාංශ. Anyway, just memorize. Principal, azimuthal, magnetic spin. Principal quantum number represents the main energy level. Azimuthal quantum number represents sub-energy level. Magnetic quantum number represents atomic orbital. Spin quantum number represents the spinning. What is spinning right now? Make a pen of the other harriet. Make spin it out. Okay, so let's look at these flips, this little thingy. So when you spin it to one single side, so it is only you are spinning to one single side. See, you spinning to, let's say this is the clockwise, and then if you go to the other side, that is the counterclockwise, that is another side. But just a single of the axis, one single axis, so that for spinning they are giving two different numbers as plus half and minus half. This is the last one. This is the spin quantum number that is inside the electron. I mean, not the inside. This is exactly the behavior of the electron. Other than other three are principal quantum number, azimuthal quantum number, and magnetic quantum number, main energy level, sub-energy level, and atomic orbital. Okay, what is the very first one? Principal quantum number. Represent, what is the symbol to represent? N. Second one, azimuthal quantum number represents L. Number 3, magnetic quantum number represents ML, the symbol. Last one, spin. This represents spinning, and the symbol is MS. Again, principal quantum number represents main energy level. What is the symbol? N. Azimuthal quantum number represents sub-energy level. Symbol L. Magnetic quantum number represents orbital. Symbol is MS. Spin quantum number represents spinning. The symbol is MS. Again, principal, azimuthal, magnetic, spin. Again, I can hear. Principal, azimuthal, magnetic, spin. Principal, azimuthal, magnetic, spin. Principal, azimuthal, magnetic, spin. Principal quantum number represents main energy level. Symbol N. It was azimuthal quantum number represents sub-energy level. Symbol L. Magnetic quantum number represents orbital. symbol MS. Spin quantum number represents, ML. Spin quantum number represents spinning. The symbol is MS. See how easy. Principal quantum number, azimuthal, magnetic and spin. Understood? ඔක්කොම ටික කටපාඩම්වත් කරලා මෙහෙම කියලා ප්‍රශ්නයක් දුන්නාම අනගන්න බෑ. හරිද? This is little complicated. Why this is complicated? Because a lot of small information are there. So I want you guys to focus now on 100%. Make sure and determine that you guys are not doing mistakes here. You are not doing mistakes once it comes to you guys to fill something, or when you are answering questions, you guys are going to do it all by yourself. Keep all the distractions away. Focus 100% here. Okay. So those are the 4 quantum numbers. This is easy. This is fun. But again, once you understand this one. Okay. Let's read this first part. Kiwana. Quantum numbers. Wave nature of electrons can be identified by solving wave functions. Integers which are used to solve wave function gives information about characteristics of electrons which revolve around nucleus. These integers are known as quantum numbers. There are 4 quantum numbers, and energy of every electron is in an atom is determined by set of these 4 quantum numbers. Having all 4 quantum numbers for a single electron is characteristic for that electron. Therefore, only one electron can exist with each set of 4 quantum numbers. Understood? Yeah. Okay. The topic is there. Let's fill this part. Okay. Fill the rest. Fill the paragraph. Done. Done. There is no space here. Can I move down? Okay, you're going to look at your note now. Look at your note. I'm going to read again. Online kids, make sure that you guys are grabbing this nicely. So there are 4 quantum numbers: principal, azimuthal, magnetic and spin. Wave nature of electrons can be identified by solving wave functions. Integers which are used to solve wave function gives information about characteristics of electrons which revolve around nucleus. These integers are known as quantum numbers. There are 4 quantum numbers, and energy of every electron in an atom is determined by a set of these 4 quantum numbers. Having all 4 quantum numbers for a single electron is characteristic for that electron. Therefore, only one electron can exist with each set of 4 quantum numbers. Clear? And make you so the only important part is the last sentence. One electron has one set of quantum numbers. Okay, so we are moving to one by one here. You guys already know, focus well. You guys already know principal quantum number represents the main energy level, and this is, you can make your own summary here. Here I have written the main energy level here. You can write other information here as well. Then you don't want any of these, then you, once you read this little part, this topic is done. You can make your own short note. You can make, usually when I'm saying that one, just try to grab whatever this concept I'm asking you guys. When you are going through reading the note, let's say as an example, so if you analyze this page, nothing is important, nothing that much important is here. Maybe like this number of photon multiplying h nu, you can just write this part instead of this whole part. Then out of this part, there is nothing that you want to gain from this one. 4 topics and only this part. So if you can highlight this, so you can write a little information here. Next day when you are reading the note, you are not reading any of this. You can read this part, but make sure before you moving into summarizing, you have to have the best memory of the page. Okay, so likewise, when you are moving to the next page, if you write all the necessary information, then you don't have to write the full page. Okay, if this represents the main energy level, and they say to represent the main energy level, they are always using non-zero positive integers. Examples 1, 2, 3, 4 and so on. Okay, you guys already know n equals to 1. What is the name of this energy level? This is the ground state, and somebody given symbols to this. Who given that? Both. What are the symbols? K, L, M, N. So nothing is new so far. So represent n equals to 1, 2, 3, 4, or otherwise you can go with K, L, M, N and so on. Then we know this is again n value increasing. What's the meaning of n value is increasing? Away from the nucleus. What do you know? Energy is increasing, energy gap is decreasing. Spectral lines are getting also closer. Yeah, I'm just explaining the same thing. See, far away from the nucleus. N higher mean you are away from the nucleus. What happened to the energy? Energy of the electron is also increasing, and this one is again, you guys know, size of the orbitals get increased. Remember I told you guys, if you go with 1s and 2s, 2s is greater. If you go with 2p and 3p away from the nucleus, orbital size is increasing, so that the 3p can, that's again 3p is greater than 2p. Clear that? Okay, so nothing new so far. By n, we can find total number of orbitals and total number of electrons. Now tell me, per one single orbital, how many electrons can accommodate? In one single orbital, how many electrons? 2. We didn't write it anywhere, but I told you guys, because to get here, I was making the background that you understand today nicely. So one orbital can accommodate all as 2 electrons. If you know the orbital number, how would you get the electron number? Multiplying that by 2 is the electron number. If you know the electron number, how would you get the orbital number? Number of orbitals. Dividing by 2. So that they say number of orbitals equals n squared. Number of orbitals equals n squared. Then what is the number of electrons? That's become 2n squared. If you know the number of electrons in main energy level, how would you get the number of orbitals? Divide this by 2, that is n squared. Clear that? Okay, so that here I'm showing that n values are going from 1, 2, 3, 4 up to infinity. When you are copying this one, you're going to copy this dotted line, simply mean you are going up to infinity. What is the meaning of infinity? That's the extent you feel the nuclear attraction. Yeah, nuclear attraction. Beyond that, there is another something. The atom is ending there. Okay, so that 1, 2, 3, 4. And what are the symbols for that? N equals to 1 mean K, 2 equals to L, 3 equals to M, and 4 equals to N. And then they say, to get the maximum number of electrons, use this little formula 2n squared. Maximum number of electrons let's say if n equals to 1, then this equals to 1 and that one is here, this one. 2 into 1 squared. 1 squared equals to 1. 1 squared equals to what? 1. It's always 1. It's always 1. So that 1 to the power 5, 1 to the power infinity, it's always 1. So that 1 multiplied 2 equals to 2. And let's say this n value equals to 2. 2n squared. Let's say this n value equals to 2. So that 2 to the power 2 is 4. 2 to the power 2 is 4. Multiplied by 2, that is 8. Okay. Same way, moving to the third energy level, n equals to 3. So this is 3. 2 into 3 to the power 2. Square value of 3 equals to 9. 9 into 2 is 18. Let's say n equals to 4. Then this n become 4 here. 4 to the power 2 is 8. Sorry. Yeah. No. 16. Sorry. This is a square value, not 4 into 2. Square value equals to 16. Multiply 2, that equals to 32. Clear that? 4 into 4, 16 into 2 is 32. Then again, I'm going to use the formula they were given here. Maximum number of objects equals n squared. Then 1 squared equals to 1. 2 squared equals to 4. 3 squared equals to 9. And 4 squared equals to 16. Okay. Now tell me, how many maximum electrons can accommodate in third energy level? Main third energy level. How many? How many electrons? 18 electrons. Understood? That's how they are asking questions such. Manjula, Aruna. May I pick a slide? Yeah. Okay, then the fourth energy level, how many maximum electrons can accommodate? 32, and this is how we are doing the calculation. And then the first energy level, how many orbitals are there? One single orbital. What is that orbital? That is S. Understood? And see, a second energy level, how many orbitals you can keep? 4. What are those 4? 1s and 3p. Understood? 1s, 3p. What is the other 5? SPD, and when you get here SPDF, I'll explain that again later. So on. Anyway, so the number of orbitals in the first energy level is 1. Second energy level is 4. Third energy level 9, and fourth energy level 16. And you guys know number of electrons here, how many number of electrons are 2 for the very first energy level, second energy level 8, third energy level 18, and fourth energy level 32. If you analyze the number of elements in this periodic table, how many elements in the very first energy level, first period? You have only 2. Why is that? Only one single energy level. What is the energy level? 1s. S can keep how many electrons? 2 electrons. So when it is 1 electron, when only there is a 1 electron, so that is hydrogen. When there are 2 electrons, that is helium. Clear that? And then the second energy level, if you go to the second energy level, so you can keep 2 electrons in S, 2 electrons in S. How many electrons in P? How many P orbitals are there? Px, Py, Pz. 3 P orbitals. Each orbital can accommodate 2 electrons. So altogether 6. So that's why 2 plus 6, 8. See, that's why you have 8 elements and 8 elements here. Understood? And this one here, 16. So that this one and this one. Okay, S2, P6 and D10. This is little different. I'll come to that later. Anyway, you have D here and also you have F here. So 2 elements, electrons, 8 electrons, 8 electrons, 16 and 16, 32 and 32. So number of elements, number of electrons are same. Okay, well, once you've done that, you're gonna get this better correlation of this. Okay, So that's all with the, let's write the n one. Yeah, that's all with the n. That's all with n or the principal quantum number. Okay, let's read this from the beginning. Then let's fill this one. Okay, let's read. Principal quantum number symbol is n. Let's read. This gives information of main energy level. This consists non-zero positive integers from 1 to infinity. Each quantum number is designated by English capital letters starting from K. मैं बोर्ड K की हुए हमें I'm just showing that. Higher the n value is, far away from the nucleus, energy of the electron gets increased, size of the orbital gets increased. N gives idea about number of total orbitals and the maximum number of electrons a shell can hold. Maximum number of orbitals in main shell equals n squared. Again, n squared, number of orbitals equals to n squared. Maximum number of electrons accommodated in a main shell equals 2n squared. Again, 2n squared. Then you're gonna fill this one. Okay, do this. Filling the table is you can do by yourself. Okay. Looking at this, fill everything. If you feel like to write that, this is S, this is S plus 3P, this is S plus 3P plus 5P, S plus 3P plus 5D plus 7F. Clear? what is the challenge with us? Challenge is to memorize everything. Otherwise, principal quantum number, the main energy level, number of electrons and orbitals are very easy. Okay, memorize this one. Then we are moving to the second one. Second one is the azimuthal quantum number. This represents what? This represents sub-energy level. And what's the symbol? Symbol is L. මොකක්ද අවුල? මේ තියෙනවා මෙතන. මොකක්ද අවුල? Finish. Anybody? Any question? Focus well. You want to finish? If you guys are not done, raise your hand. Just ask me, not go forward if you guys are not finished. Okay? Because I don't see that you guys are writing. That's why I'm going forward. Okay. Then azimuthal quantum number. See. This talks about sub-energy levels and how would you get sub-energy levels? See, if you know the n value, to get L value, what you're supposed to do is you're going to go from 0 to n minus 1. So for L, 0 is possible. But for n, 0 is not possible. If you know the n value, then 0 to n minus 1. Let's say your n value is 3. n equals to 3. Then this becomes 3. 3 minus 1 equals to what? 2. Then 0 to 2. What are the values then? The values become 0, 1 and 2. Say that. Let's say your n value is 1. If your n value equals to 1, then this is become 1. 1 minus 1 equals to what? It's 0. 0 to 0 mean what? 0. So L equals to 0. Clear that? Let's say your n value is 5. Let's get a little larger one. This is 5. Then L equals what? 0 to 4. So L equals what? 0, 1, 2, 3 and 4. Understood? That way you are getting L values. Plus, see, මෙන්න මේකයි මම කියන්නේ ඔයගලන්ට මේක දිගටම whenever you are going on, you would see this like the easiness when you are doing English medium. See the symbols. They have given symbols for these different L values. L values starting from 0 to infinity, 0, 1, 2, 3 and so on. If the L value is 0, then the symbol is S. L value is 1, symbol is P. L value is 2, symbol is T. L value is 3, symbol is F. See, මේ බලන්න ඔයගලන්ට how easy ද කියලා. Sharp, principal, diffuse, fundamental. මේ ටික ඔයගලන් separately memorize කරන්න ඕනේ. ඒක ගොඩක් තියෙනවා English වල. English, chemistry කල්පනා අමාරුනේ නේද? මේ 3 වල ප්‍රධාන විසාරේ මූලික කියන හතර ඔයාලට මෙන්න මේ අකුරු වලට මතක තියාගන්න ඕනේ. That's sort of difficult, but you guys already get that because they were taken S, P, D and F. Okay. Now tell me, if the L value is 2, what is the symbol? D. Now tell me, for D sub-energy level, what is the L value? It's 2. Clear that? Back and forth, you're supposed to think. And tell me, what is the L value for P sub-energy level? 1. If the L value is 1, it represents what? P sub-energy level. Understood? Clear that? Okay. So that is that. Each of these. And since you guys know, when L value is 0, it represents S. When L value is 1, it represents P. What is the shape of S? Symmetrically spherical. Then what is the shape of when L equals to 0? Symmetrically spherical. What is the shape when N value equals to 1? Symmetrically dumbbell. Got that? So back and forth. n value equal to 0, then the shape is spherical and so on. And then another something is number of orbitals equals to number of sub-energy levels. Sub-energy levels exactly equal to n value. See, make it a okay, annotation here. Let's say if we know the n value goes from 0 to n minus 1. 0 to n minus 1. Then if we calculate this number of sub-energy levels, that exactly equals to the n value as well. See, so n value is going from 0 to n minus 1. This is going from 0 to n minus 1. If the n value equals to 1, now you have to focus really well because N or L, same sort of pronunciation. So symbols are different but pronunciation are sort of same. Okay, let's say n equals to 1, then I'm going to substitute here 1. 1 minus 1 equals to 0. 0 to 0 means 0. Then let's say n equals to 2, then this is become 2. 2 minus 1 is 1. 0 and 1. So you have two values, 0 and 1. When this is 3, when n equals to 3 here, then 3 minus 1 equals to 2, 0, 1, 2. If you get number 4 here, if this is 4 here, 4 minus 1 equals to 3. So it's 0 to 3 means 0, 1, 2, 3. So I'm going to count the number of sub-energy levels. I'm going to count number of sub-energy levels. Here you have just a 1. Number of sub-energy levels equals to 1. See, number of sub-energy equals to 1. 1, 2, it's 2. 1, 2, 3, 3 sub-energy levels. 1, 2, 3, 4, 4 sub-energy levels. If you compare this one with this one, see exactly n value and number of sub-energy levels are equal. N value 1, 1 single sub-energy level. N value 2, 2 sub-energy level. N value 3, 3 sub-energy level. N value 4, 4 sub-energy levels. Clear? Okay, back and forth. You guys have to memorize this now. Understood? Okay. And then S one maximum electrons theatre. How many electrons? 2. Why? S has only one single orbital. P, how many orbitals do you have? 3. Then how many maximum electrons? 6. D, sub-energy level, how many orbitals? 5. Each accommodate 2. 5 into 2, how many maximum electrons? 10. F, how many orbitals? 7. Each accommodate 2, that's 14. We know already. There are different methods you can get the answer. Not one single method. There are a couple of different methods. You can know that already, but still there is another method to calculate the maximum number of electrons if you know L value. To calculate the maximum number of electrons, you are using this formula 2 into 2L plus 1. Knowing the L value. Okay. So that, let's say L value is 0. Then you're going to substitute this L as 0 here. See? 0 into 2 is 0 plus 1 is 1. 1 into 2 is 2. Let's say L value equals to 1. Then you are substituting here 2 into 1 here. 2 into 1. 2 into 1 is 2 plus 1, 3. 3 multiplied 2 is 6. When L value equals to 2, then you're going to multiply or you're going to substitute here 2. 2 into 2 equals to 4 plus 1, 5 into 2 is 10. Let's say L value is 3, then you are substituting 3 here. 2 into 3, 6 plus 1, 7 multiplied 2 is 14. If you know the L value, you can calculate total number of electrons. Clear that? If you know N value, you can calculate total number of electrons. What is that? 2 n squared. Very good. 2 n squared. If you know N value, number of total electrons in main energy level is 2n squared. If you know L value, what's the number of total electrons in that particular sub-energy level? 2 into 2L plus 1. Clear that? Okay. Focus and memorize. Otherwise, this is very easy. If you break all these parts into different little portions, understanding is very easy. But as a whole, memorizing is the issue. Memorizing is the issue. And another little something is there, they say, since this is giving the information about the angular momentum, azimuthal quantum number has another name, that is the angular momentum quantum number. Clear that? Angular momentum quantum number, because it gives information about the angular momentum. Okay. Let's read. Topic number 2. Azimuthal quantum number, symbol is L. This gives information about some energy level. For a given n value, L can have values from 0 to n minus 1. Each L value is designated by a symbol as follows. When L equals to 0, S, 1, P, L value is 2, that's G, L value is 3, that is 4. You're going to mention the symbol as well. The symbol of quantum number is L. Okay. Okay, copy the table. Okay, a lot of students are absent today, so support your friends when you are explaining these things to them. Okay, when they are asking questions, just explain nicely. Okay, let's read this part. Next point. For a given energy level, the sequence of filling electrons in sub-energy levels proceeds the order SPDF. Why is that? First filling to S, then P, then D, then F. What is the reason? You guys know. Always, what matters? Energy matters. Why they are filling to S? Energy is supposed to be the least. Yeah, the lowest energy is supposed to go into S. That is the truth. See, energy increasing this way. S has the least energy. F has the highest energy. You need to, we're going to do this big topic hybridization. Then always you are filling the very first electron to S orbital, because that has the least energy. Energy is equivalent to the electron. Whatever the energy level they are in, that energy is equivalent to that electron. If it is in low energy levels, that electrons are more stable. That's why they are existing like that. Let's read again. For a given energy level, the sequence of filling electrons in sub-energy levels proceeds the order SPDF. For a given energy level, energies of sub-energy levels get increased in order of S, P, D, and F. L value also gives an idea about shape of the orbital. When L equals to 1, it is spherical. Total number of sub-energy levels for a given energy level is equal to its n value. Let's fill this part and let's move on to the table. energy level, the sequence of filling electrons in sub-energy levels proceeds the order SPDF. For a given energy level, energies of sub-energy levels get increased in order of SPDF. L value also gives an idea about shape of the orbital. When L equals to 0, it is spherical. Total number of sub-energy levels for a given energy level is equal to its N value. Make a figure. Complete the table. Anything to ask? Shall I come to you? Any question? No. Raise your hand, I'm coming to you. Whenever you feel like something uneasy, raise your hand. I want you guys to represent the, copy these dotted lines as well. Finish? Okay. Check your table. Check your table. Finish. All right. Let's read this little part. Maximum number of electrons that can be accommodated in a given subshell. Subshell means sub-energy level is equal to what? 2 into 2L plus 1. Again. 2 into 2L plus 1. Okay. Fill that and fill the table. Even without the formula, you know how to get the answer. One of the final paper questions coming from Unit 1 always is from this. Least one single question coming from the quantum numbers are there. අපි Unit 1 ඉවර වෙලා exam එකක් කියමු. පාඩම් කරන්න ටික ටික පාඩම් කරගන්නකො. I just want to, I'm not judging you guys. I want to make sure that you guys done this correct. You guys are memorizing things and everything. Harder. Check it. Check your table. Shall we move on? angular momentum quantum number. Fill that. The line is not there, but fill it. So that we call it angular momentum quantum number. Okay, with two quantum numbers. Okay, what is the next quantum number? Magnetic quantum number represents what? That's a symbol. Represents what? Orbiters. Orbiters. Yeah, symbol is ML and it represents orbiters. So this is my, see, if I go, no, I'll go back later and explain everything. Okay, so if you know n values, how would you get L values? 0 to n minus 1. Same way, if you know L values, to get ML, you are going from minus L through 0 to plus L. Minus L through 0 to plus L. Let's say L equals to 2. Then what are MLO, magnetic quantum number values? Minus 2, minus 1, 0, plus 1, plus 2. Let's say L equals to 0, minus L through 0 plus L equals to what? L equals to just 0. There is no minus L, minus 0 plus 0. It's just 0. Clear that? Let's say if L equals to 4, then ML equals to what? Minus 4 to 0 plus 4. Then the values are minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4. Clear that? Okay. So that's how you are getting orbiters. On about one correlation එකක් දෙනවා ඔයගලන්ට. මෙහෙමනේ දැන් යන්නේ. So L value, if the L value is 0, what is the ML value? Just 0. And if this is 1, then the table L equals to 0, then ML equals to what? 0. Let's say if this is 1, ML equals to minus 1, 0, plus 1. Let's say if this is 2, then the values are minus 2, minus 1, 0, plus 1, plus 2. එතකොට මෙතන එකකට මේ ඉන්නේ 1යි. ඔහා මොකද හිතන්නේ? මේ එකකට මෙතන ඉන්නවා 3. මේ දෙකකට ඉන්නවා මෙතන ඉන්නවා 5. මොනවා කියලාද මේ හිතන්නේ? Orbiters. Orbiters. Okay, L equals to 0. What is that sub-energy level? S sub-energy level. S sub-energy level has how many orbiters? 1. So this is that orbiter. This is that orbiter. When L equals to 2, what is that sub-energy level? What is that sub-energy level? P. P sub-energy level has how many orbiters? 3. That is these 3. Minus 1, 0, plus 1, Px, Py, Pz. See the correlation. And then L equals to 2 represent what sub-energy level? D. D has how many orbiters? 5. These 5 are minus 2, minus 1, 0, plus 1, plus 2. See, always back and forth there are connections. Whenever you are doing questions, there are plenty of different methods you can get answers. It's not one single method you are memorizing. Anyway, so if we come back to this little thingy, if you know NL, so if you know L value, I hate black, I don't know why. Some love black. I hate black. I love white. My favorite color. Anyway, so if you know L value, I elaborate as well. If you know L values, to get ML values, you are going from minus L through 0 plus L. And also, to find the number of orbiters, the formula is 2L plus 1. දැන් මට කියන්න sub energy levels වල formula එක මොකක්ද? Number of sub energy levels is what? 2 to 2L plus 1. එතකොට sub energy levels වලින් orbitals ගන්න එක divide by 2, 2L plus 1. Clear that? Always remember this correlation. So that this is here I'm explaining. If you know the sub energy level symbol or whatsoever, if you know the symbol or whatsoever, S mean L value is 0, P mean L value is 1, D mean L value is 2, F mean L value is 3. If you know whatever the way, if you know this L value, whatever the way, if you know the L value, this is L value. So you get ML value, minus L through 0 plus L. For 0 is 0. If it is 1, minus L plus L become minus 1 plus 1. So minus 1, 0 plus 1. If it is 2, minus 2 to plus 2 become minus 2, minus 1, 0 plus 1 plus 2. If it is 3, minus L through 0 plus 3. Minus 3, minus 2, minus 1, 0 plus 1 plus 2 and plus 3. Clear that? And otherwise, see, main number එක අපිට මෙහෙම calculate කරන්න පුළුවන්. What is the meaning of ML? What's the meaning of ML? ML represents what? Orbitals. Orbitals. So this is not orbitals. Okay, number of orbitals is equal to what here? මොන කිව්ව එක? 0 orbital. නේද orbital එක ගන්න නැහැ නේ. How many? Just a 1 here. Neither. So that equals to 1. How many orbitals are here? When L equals to how many orbitals? 1, 2, 3. 3 here. 1, 2, 3, 4, 5. 5 here. 1, 2, 3, 4, 5, 6, 7. And 7 here. Either you can get answer that way or otherwise you can calculate using 2L plus 1. Different methods are there. Are you guys okay here? Okay. බලමු මේ ටිකක් දාගෙන ඔළුවට. See? මේ තියෙන්නේ. So these represents either you can say minus 1, 0 plus 1. L equals to 1. So ML equals to minus L through 0 plus L become minus 1 through 0 plus 1. That is minus 1, 0 plus 1. Either you can say Px is minus 1, Py is 0, Pz is plus 1. Or otherwise මේක මාරු වෙන්න පුළුවන්. This is plus 1, this is 0. Same do නේද? This is plus 1, this is 0, and this is minus 1 කියලා. Even this way you can show that as well. Anyway, these Px, Py, Pz represents minus 1, 0, and plus 1. Okay, let's read this. Topic number 3, magnetic quantum number. The symbol is Ml. This represents orbitals. This gives information about orbitals. For a given L value, possible values for ML is from minus L through 0 plus L. Total number of orbitals in a given sub-energy level equals to 2L plus 1. If you know L value, how would you calculate number of orbitals? 2L plus 1 again, 2L plus 1. Okay, feel that? I should have made the time today as 5:30. I totally forgot that. Is there anybody like having with this, like, you know, the challenges with flood or something? Getting data, you cannot leave or something? අපිට time එකේ stress එකක් නැහැ because we are covering the syllabus so much ahead of time. So we have like time in case if there is this like very necessary something. And 27, 2027 set එක හොඳට marks දැම්මනේ first term test එකේ. I wasn't thinking. ඒ කියන්නේ 95.5 වගේ ලකුණක් ගන්නවා කිව්වහම ළමෙක් නේද එනමට ආයේ අමතක වෙච්ච නැති වෙච්ච තැනක් නැහැනේ. So paper class එකේ support එක yeah 95.5 yeah. So that make sure that you are coming to paper class. The magic came through the paper class. Finish. Okay. Copy this. information of the orbiters. Is there anything to fill there? Yeah, fill it. This gives orientational information of the orbiters. Copy this part. Okay, one more. After that, let's go to the break and then come back and fill the table. Moving on. Last one is the spin quantum number. There is nothing to explain. You have two different spinnings, either clockwise and either counterclockwise. That's all. Okay, let's read this. Number 4, spin quantum number. This represents actually spinning. The symbol is ms. This gives information of self-rotation of electrons. An electron spins around its own axis while it is moving around the nucleus, like Earth is moving around Sun, spinning around itself, moving around Sun. This is known as self-rotation or self-spinning. Electron can rotate around its own axis in two ways. Depending on that, we can assign two possible values as plus half or minus half. මේ දෙකේ questions වෙනම කවදාවත් ඇහිලා නැහැ. අහන්නත් බෑ. කියන්නේ whether it's plus half or whether it's minus half, it doesn't matter. It doesn't matter. So whatever their question asking, they're asking from the first three quantum numbers: principal, magnetic, and azimuthal and magnetic. Those three are the questions they are asking usually. Okay, copy this. Spin quantum number ms. Any question, anything? මම ඔයගොල්ලන්ගේ forcefully අහන්නේ තාමත් ඔයාලගේ මූණ වලින් මට පේන්නේ මාත් එක්ක ගොඩාක් friendly කියලා. චුට්ටක් බයින් වගේ ඔයගොල්ලෝ තාම මන් දිහා බලන්නේ. එහෙම වෙන්න එපා. ටක් ගාලා අත උස්සලා මොන දෙයක් අහන ගන්නට හැදෙන්න. I really love when this class is going as like this discussion something. Discussion group එකක් වගේ යන්න try කරන්න. අර questions තියාගෙන grand gate එකකින් එළියට යන්න එපා. Questions ටික sort out කරගෙන යන්න. Okay, let me read this again. This gives information of self-rotation of electrons. An electron spins around its own axis while it is moving around the nucleus. Shush. This is known as self-rotation, self-spinning. Electron can rotate around its own axis in two ways. Depending on that, we can assign two possible values as plus half and minus half. Copy this. Remember the last week when you went to this quiz, I guess you guys got a lot of time. How much break time you guys needed? 1 hour. Kavi, 15 minutes enough? 20 minutes? Yeah, since we are going with like up to 6 and since it's raining today, I'm giving 20 minutes. But then it's must that you guys are get here before that 20 minutes. When I'm sitting here, you guys have to sit here. Otherwise, next week, I will 15 minutes. Fine. understood? If you behave nicely, I'm giving you guys 50 minutes, 20 minutes, otherwise it's 15. Actually, today it's not raining there. The last week we had rain, remember? Finish? What time is it? Angela finished? No? Finished. Okay, online quiz as well, break time. 4:08, let's say 4:10, you're going to come at 4:30. 20 minutes is, anyway, मैं market time making and only 20 minutes then you guys have to get here in another 20 more minutes. Come back at around like theater, 4:30. Get here around 4:30. Get here, let's start this. Are you there? යාළුවනේ දිගින් බලින්න. හරි. Principal quantum number n represents the main energy level. So n is the symbol of the main energy level, and that also each of these different energy levels are having symbols. Those are when n equals to 1, n equals to 1 that is k, n equals to 2 that is l, n equals to 3 that is m, and n equals to 4 that is n. So that you guys can understand easily. And then number of sub-energy levels exactly also equals to the n value. So since I have written n1 here, 1, second energy level, 2 sub-energy levels, third energy level, 3 sub-energy levels, and fourth energy level, 4 sub-energy levels. Clear that? Okay. That part is easy to understand. And then okay. Let's move on one by one. And the next one is the azimuthal quantum number. Azimuthal quantum number symbol is L. If you know the n value, you can get the azimuthal quantum number from 0 to, hurry up, guys, come on. 0 to n minus 1. 0 to n minus 1. So that the value are going from 0 to n minus 1. Where is Sanya? Sanya nediya? Where? On the way. Tiyawu කරන්න එන්න ඕනේ. Okay. See, if you know the n value, this is 0 to n minus 1. And this is ml. ml represents what? ml represents magnetic quantum number. Magnetic quantum number represents sub-energy levels. Sorry, orbitals. Orbitals are getting when you know L values. If you know the L values, ml values become minus L through 0 plus L. And also, if you know L value, you can also calculate total orbitals, which equals 2L plus 1. We know L values. From that you can find ml values and also number of orbitals. This is always see. That's what I'm saying. You supposed to have no worries about this spin quantum number. It's either plus half, either minus half. It's always same. So each of these orbitals always are having like 2 electrons in each of these orbitals. Okay. Then I'm coming back to the very first one again. Let's say n equals to 1. n equals to 1 represents symbol K. Number of sub-energy levels again 1. here. And then, if you know the n value, L values are going from 0 to n minus 1. 0 to n minus 1. If this is 1, 0 to 1 minus 1 is what? Manchula, hesanna කොහෙද දරුවනේ? කොහෙද හිටියේ? ඔයගොල්ලෝ පස්සෙන් ආවා කිය කොහෙද ආවයා? මංජුලා පුතක් බලන්න. ඔව් බෝස් ටික. හොඳයි නේද? තෝනි ඊට පස්සේ තනියම මෙහෙම යන්න බෑ යාළුවොත් එක්ක එකට එන්න ඕනේ. හරිද? හ්ම්? හරි. බෝයිස් ලා කට්ටිය දැන් කළා? පරිහරිනවද? සීරියස්ලි. අයින් නැත්තේ. මේ පාට් එක ටිකක් ඉක්ම ගන්න බෑ පස්සේ කියා දෙන්න ලේසිත් නෑ. මට ආයෙ මෙච්චර වද වෙන්නත් බෑ. If you know the L value, if you know the N value, you are getting L values. Okay, focus here. L values 0 to n minus 1. Let's say n equals to 1. So this is to become 1 minus 1. So 0 to 0. So it is just 0. Then you are just writing this 0 here. Okay. Then L value equals to 0. I'm going to go to ML values. Going from minus L through 0 to plus L. If this is 0, this is exactly again 0. Because here you have minus 0 through 0 plus 0. There are no such like minus 0 and plus 0. So that value is just exactly same 0. This is also become 0. Clear that? Number of orbitals, again you are getting through L values. If you know the L value equals to here 0. So that this is 2 into 0 is 0 plus 1 is 1. So that this total orbital is 1. Are you guys following me? Clear this? Okay. And then ms, regardless whatever it is, ms always plus half and minus half. Plus half and minus half. It's not changing. Plus half and minus half. Then number of electrons in a single orbital. Always what? Always each of these orbitals are having only 2 electrons in each orbital. So this is always 2. And then number of electrons in sub-energy level. Sub-energy level L value. L equals to 0. 2 into 0 is 0 plus 1 is 1. 1 into 2 is 2 here. And then again number of electrons in main energy level, the last one. That's again, since this n value equals to 1, then we need 2n to the power 2 into 1 to the power 2. So 1 to the power 2 is 1, so that's 2. So ඔයගලන්ට buns ගැන අහලා plain buns ගැන අහලා ඉස්සර පරක්කු චෙක් දෙන්න එපා. ගන්න එක එක ගන්න. දෙන්න එපා buns දෙන්න එපා පරක්කු වෙච්ච කට්ටියට. How come you guys are being that late? Seriously. Even I've given 20 minutes. Next week එකේ ඔයාලට දෙන්නේ 15 minutes. 20 minutes දෙන්නේ ආයි. හරිද? Next week එකේ break time only 15 minutes. Okay, then I'm moving to the second energy level. බන් එක දිහා බලන්න නැතුව lesson එක දිහා බලාගෙන බන් එක ගන්න. Okay. So, we are moving now to the n equals to 2. Focus well. Okay. Answer to thank you කියන්නේ ඉතින්. ඇහුන්නේ නැහැ. දෙන්න නැනේ. මං කිව්වා late වෙච්ච කට්ටියට දෙන්න එපා කියලා. පාලිද 20 minutes I've given today. And I asked them to make sure that they are here before 20 minutes, but they're still being late. ඒක නිසා next week එකේ දෙන්නේ 15 minutes. යාළුවෝ යාළුවට බැලලා ගෙන්න ගන්න ඕනි කලින්. එතකොට තමයි ඔක්කොම දෙන්නේ 20 minutes. Okay. Listen. n equals to 2. n equals to 2. I'm moving to n equals to 2. So that symbol is L. equals to the number of sub-energy levels. N value is exactly equal to number of sub-energy levels. So that the number of sub-energy levels, so that equals to, if this is 2, this is also 2. So we sorted out up to here. Okay, now 2. When n value is 2, n value is 2. When n value is 2, and then L values are getting from 0 to n minus 1, 0 to 2 minus 1. So values are, what are the values? 0 and 1. So values are 0 and 1. Okay, focus only here. This is the second main energy level. We know the n value that exactly equals to the number of orbitals, and then we need this n value to get L value. So L values are 0 and 1. Then again, exactly same way, look at here, don't distract yourself. Okay, then again this here, if the L value is 0, from this 0, if the L value is 0, from this 0, I'm trying to get ml values. 0, 0, minus 0 through 0 plus 0 means just 0. So that this is again become exactly 0. Clear that? And then since L is 0, 2L plus 1 is what? L value here is 0. 2 into 0 is 0 plus 1 is 1. So that again this is become 1. This is always plus half minus half. This one single orbital having 2 electrons. So we are done up to here. Then number of sub-energy levels, if you know the L value. L value is 0 here. So that 2 into 0 is 0 plus 1 is 1. 1 into 2, that value is again 2. So that you can get up to here. This is again 2. Are you guys okay up to here? Clear? Focus really well. I'm going to show this one. You are filling this. Don't fill now. You're going to fill this by yourself. Don't write anything now. But once I'm explaining, you're going to fill this by yourself. Okay, then I'm moving to this here. Okay, this one is done. 0 is done, but I have two L values, 0 and 1, I'm moving to 1. If the L value equals to 1, if the L value equals to 1, from this one again I'm going to get ml values. How? Minus L through 0 plus L. If this is 1, this is become minus 1 through 0 plus 1. So values are minus 1, 0, plus 1. So these are the three values, minus 1, 0 and plus 1. Clear? If you want to calculate number of orbitals, L value equals to 1, 2 into 1 equals to 2, 2 plus 1, 2 plus 1 equals to 3. So that this is become 3 here. Clear? This is 3 here. Plus C. If you want to go 1, 2, 3, again, this is 3 here. Total orbitals. Now you guys know, these three are Px, Py, Pz. So 1, 2, 3. So that actually is 3. These three are 3 orbitals. Each of these orbitals, minus 1 orbital has plus half, minus half. 0 orbital has plus half, minus half. Plus 1 orbital has plus half, minus half. Anyway, 1, 2, it's 2. 1, 2, it's 2. 1, 2, it's 2. 1, 2, it's 2. So each of these orbitals again now having 2 electrons in each. 2 electrons in each. 2 here, 2 here and 2 here. Understood? All together in this 2p orbitals, how many electrons? That's 6. 2s, that actually is 2. That's why the second main energy level between these two blue lines are having 6 plus 2, 8 electrons. But again, if you want to calculate this 6 knowing L equals to 1, 2 into 1 is 2, plus 1, 3 into 2, that is 6. If you want to calculate the total number of electrons, you are going with n value here. N value here is 2. 2 into 2 squared. 2 is, n is 2. Then 2 to the power 2 is 4 to the power, 4 into 2 is 8. By that, again you can get same 8. There are different ways. Either you can get 2 here, that's 2. Then 2 here, 2. These 3, 6. These 2 together, 8. Or otherwise, you can calculate this one, this 2n squared to this one, 2n squared to this one as well. Have you guys understood? Is this clear? I know this is little confusing. Focus really well. Okay, then again, this is the main or the principal quantum number, and it has one single sub-energy level, 0, that has one single orbital, that is 0, so the number of object is 1, that has 2 electrons. So this total, the very first energy level can reside always only 2 electrons, and this is in the very first energy level here, so that we name it as 1. 0 represents what? What is the symbol for 0? L equals to 0 means, what is the symbol? S. So that this same one I can name as 1s. See the 2s. Main energy level is 2. 0 represents s. So this is become 2s. This actually is 2s. Same way, this represents 2. And 1 represents p. So that we can say, instead of saying just L equals to 1, you can say that energy level is 2p energy level. Understood? Clear? Are you guys okay? I know, if you guys being late to get to the class, you cannot focus enough. I'll come to you guys to explain that, but other than that, I guess you guys are okay here. But still, now I'm going to the next energy level. Now it's a little more complicated. But I'm doing exactly the same thing. You guys can just go through this way. Understood? Okay. See, now I'm moving to n equals to 2. n equals to 2. So මට කියන ආයසරයක් කියා දෙන්න කියලා. ආයසරයක් කියා දුන්නොත් ටයිම් එකක් යන වෙයි කියා දෙන්න විතරක්. දැන් ওই ටිකම මම ආයෙත් මේකට කියා දෙනවා. දැන් ඔයගලන්ට මම 0 කියා දුන්නා. ඊට පස්සේ 0 and 1 කියා දුන්නා. We are done 0. We are done 0, 1. Then I'm going back to 0, 1 and 2. Focus really well. Exactly same thing I'm explaining. Okay. When n equals to 3, so the symbol is m. Symbol is m. Okay. And then again, when n equals to 3, number of sub-energy level equals to 3. Plus, when n equals to 3, I'm going to get L values from how? 0 to n minus 1, 0 to 3 minus 1. What are the values? 0, 1 and 2. So that I have 3 different values, 0, 1 and 2. Exactly same way you are going with 0 here and 1 here, only 2 is different here. Understood? Exactly same 0. Anyway, if the L values, I am here now. Now I'm here. Now I'm here. My third energy level. Now I'm here in between these two. Okay? So anyway, since this is 0, see the L value is 0. When L value is 0, ML is going from minus L through 0 plus L. That actually is 0. So the value here is 0. Understood? This is 0. I'm going through this now, okay? This is again 0. I'm going with blue. This is 0. This is 0. And then number of orbitals again. Number of orbitals when L value is 0, 2L plus 1. 2 into 0 plus 1, that again is plus 1. Only 1 here. So that is 1 here. One single orbital always having plus half and minus half. So that those two. That orbital has how many electrons? Always 2 electrons. So that's again this 2 here. 2 electrons, that's again 2 here. L value 0. See, this is the L value. L value 0. If the L value is 0, 2 into 0 is 0 plus 1 is 1 into 2. That's again 2. Number of electrons in sub-energy level again is 2. Understood? And then, now I'm done with 0. I have 1 and 2. Because here 0 to 3 minus 1, 0, 1, 2. I'm done with 0. I'm moving to 1 again. We are moving green negative. Okay, I'm going to go with green here. 1 here. If this is 1 here, minus 1, 0, plus 1 are these 3. Are you guys okay? Are you guys following me? And then 1, 2, 3, you have 3 total orbitals, or otherwise, knowing L value here, L value equals to 1. So 1 into 2 is 1, 1 plus, sorry, 1 into 2 is 2, plus 1, 3 orbitals you can get here. Whatever the way you can do that. Okay, so I'm done up to here and then here. See, each of these orbitals, these are orbitals. Minus 1, 0, plus 1. Each of these are having plus half, minus half. So each of these are having 2 electrons. So that this is the pink part. This pink part is the p orbital. How many electrons together? 2, 4, 6. So that's 6 here. That 6 and these 2 are there, but still we are not done. Then we're going to move on to n equals to, purple, n equals to 3. Then again, from here, you are going here. If you know L value, you can calculate ml value, minus L, 0 plus L. That is become 2. So that minus 2, minus 1, 0, plus 1, plus 2. So that you have minus 2, minus 1, 0, plus 1, plus 2. These are orbitals. Each of these orbitals are having, see, 2 electrons of each. If you know this L value is 2 here, if L value is 2 here, 2 into 2 plus 1, that is 5. So you have here 5 orbitals. See, number of orbitals is 5. Each of this is having plus half, minus half. Each of this is having 2 electrons in each. And if you calculate here, you have 2 here, you have 6 here, you have 10 here. All together is 18. Either you can get that value using this one here or using this one here. Clear that? 10 ගන්න ඇත්ත එහෙමයි. Are you guys okay here? දැන් මේක තනියම කරන level එකට පොඩි idea එකක් ඔළුවට ආවද? Can you guys do this all by yourself? Once you've done this, I want you guys to support maybe the front row or maybe the back row. If you guys done, if your adjacent friends are done, then support each other to fill this. I want you guys to support each other to fill this. Okay? Okay, give it a try. Everything is nicely tabled. You just need to fill this. Hang in. Pencil. No pen. Only the pencil. Because I'm going to show this one. Let's go with the pen. ඔගොල්ලෝ මට නොදී තනියම බන්ස් කෑව හරි නරකයි. රසයි නේද? කෑවේ නැද්ද? කො බන් එක? ඇයි කන්නද ඕනේ? තාම බන් එක අතේ තියාගෙන නැහැ කියන්නේ? ඉතින් අපි දෙන්නෙක් ඉන්නවා. මෙන්න තාම මේ උගලගේ බන්ස් තියෙන මේ තව තුනක් බන්ස් තියෙන ඕනනම් කන්න අනිත් අය අරගෙන. මේ ඇති වැඩේට බහින්න. Okay, feel this though. කාගන්න බයිද ඒකවත්? Seriously. ඔයා අරගෙන කන්න සුදුද? පොතෙන් ඔක යාළුවට කන්න බයිද? Okay, go on. Ready? එන්න ඔයාව කොපි කරනවද? තනියම. තනියම. If it is difficult, I'm supporting you. කො බලමු කාටද අවුල් කියලා වැඩි. ඒ කලින් කියන්න. හරි එනවා. ඒ කියන්නේ තෙමුනට පස්සේ අර නිකන් ස්පොන්ජ් කේක් එකක් සෝප් වෙනවා වගේ ඔයගොල්ලෝ ඩිසෝල්ව් වෙලා ගියාද කකුල් එහෙම නිකන් ඇවිදගෙන යන්න බැරි. ඊට මොකද කරන්නේ? ඈ? ඉතින් එළියට ආවනේ. මේ කපඩි කොල්ලා. කොහමද වෙන්නේ? ඒ කොහොමද කරන්නේ? kids are also having this. Make sure you got this correct. And next day at the class, I'm going to discuss this again during the next day. I know this is really, really challenging. I told you guys, when you are doing the theory, it's very easy. But when you're filling this one, it's really challenging. So this is how you're supposed to finish it. At the end of the day, this is the table. Okay, now complete everything. Just go back and forth with the note. I'm coming back to you. If you still feel uncomfortable, I'll support back. No, if you don't feel like, go back and forth with the note, but really okay. Really okay. Then okay. Completely okay. ಯಾವಾಗ ಓಕೆ ಮಾಡಿ ಪರತ್ತ ಓಕೆ ಮಾಡಿ ಯಾಕೆ ಪುನಃ ಕೈ If you guys are reading okay, I want you guys to fill this one with the pen. Use the pen now, complete this. If you guys are really okay, use the pen to complete this now. That pen එක fill කරලා නැත්නම් note එකේ weakness එක. So the note are casting like what it. You don't eat later. Later. Okay, remember, if you go here, this is explaining how you are getting these values. Whenever you have any sort of a L value, if you know the L value, how would you get ml? You are getting ml. If you have the L value, you are getting ml minus L through 0 plus 1. If it is 0, minus 0 through 0 plus 0 is 0. මම මේ ටික අච්චර ඔයගලන්ට කියා දුන්නේ ඒකයි. Like at that time you were feeling like it's too much. I'm explaining like a teeny weeny bit of everything. But now you know it's complicated. That's why I have explained everything really nicely and slowly. Let's say if L value equals to D, then L value equals to 2, then you are going from minus 2, 0, plus 2. See the minus 2, minus 1, 0, plus 1 and plus 2. So that when you are filling here, when n value equals to L value equals to 2, then you are going from minus L through 0 plus L become minus 2 through 0 plus 2 become minus 2 minus 1 0 plus 1 plus 2. That is these 5. Minus 2 minus 1 0 plus 1 plus 2. Okay, once you've done that, same way, see, I know this is really complicated, so we're going to do a lot of questions, and we have a lot we have a lot of questions in your tude book as well. Go through the tude book as well to get questions so that you can feel comfortable. And remember, so that if this is 2, you have minus 2, minus 1, 0, plus 1, plus 2. If this is 1, even here or even here, minus 1, 0, plus 1. Minus 1, 0, plus 1. Clear that? That's how it is going. And see again, if it is n equals to 0, n equals to 1, then you have one single energy level. So that is always for S1s. If it is 2, you have 2s and 2p. If it is 3, n equals to 3, you have 3s, 3p and 3d. Then when it comes to 4, then what happened? This is supposed to be 4s, 4p, 4d and 4f. And remember, S always has 2 electrons. S always has 2 electrons. P has 6, D has 10 electrons, F has 14 electrons. So altogether it is 32 electrons. Are you guys there now? Okay. Evan, are you feeling comfortable? Not yet. Still no. Okay. Because I guess you guys got late at the class, just go home and do the recording. අහන්නකෝ ඔයාලා හැමෝමලා කවදා හරි දවසක මේ ලංකාවේ නෙවෙයි මේ ලෝකේ respectful human figures ලා වෙන්න ඕනේ when you become like let's say ඔයගලන් වයස 30 වගේ වෙද්දි. ඒක තමයි මගේ ටාගට් එක. මම ටාගට් කරන්නේ ඔයගලන්ට කෙමිස්ට්‍රි වලට ඒකක් දෙන්න හරි ඔයගලන් ලංකාවේ කැම්පස් එකක ට්‍රැක් කරන්න හරි. මගේ ටාගට් එක after 10 more years how much high flying life you can reach. I was experiencing everything, so such beautiful life I want you guys to experience. That is my target. To complete that target, I'm always giving you guys the best these instructions. If you feel bored of doing this one, you can do this. ඔයාලට bored නැත්නම් ඔයගොල්ලෝ ගෙදර ගිහිල්ලා ආයෙසරයක් මම කියා දීපු දේවල් හොඳට අහන්න. දෙවෙනි සැරේට අහද්දී ඔයගොල්ලන්ට සමහරට frustration වගේ දැනේ because each and every single explanation I was just substituting always like continuously when we were doing all those topics separately because I know this part is complicated. It's not difficult, complicated. So once you're done during this week and when you are coming to the class next day, I am explaining this again. Same way you understood hydrogen spectrum, that you are understanding this quantum numbers as well. Next week I'm also going to do this part. Other than, I know Evan is still not feeling that comfortable. Anybody else feeling uncomfortable here? Because I'm going to move on now. He's okay. He's doing little okay. With your support, he would get that. With Buddha's support, I will then know it. Itu tik karate. Can we move on? Are you guys done up to here? Okay. Go through the recording. Once you get to the class next day, I'm explaining this again. Okay. So the next thing is the question. You would understand everything through questions. Okay. Next question. Identify the correct set of quantum numbers which are possible for a given electron. Okay, look at the screen. Look at the screen. Everyone, look at the screen. Let's get the best practice. Then we go to the questions. So that whatever the question you come across in this whole syllabus, you can do that. I'm moving on with the very first one. They want us to identify the correct set of quantum numbers. If I go with the very first one. When n value, if you know the n value, how would you get the L value? If you know the n value, how would you get the L value? 0 to n minus 1. If you know the L value, how would you get the NL value? Minus L through 0 plus L. This is always what? Plus half or minus half regardless. You don't worry about this line there. So I'm moving on to the very first one here. When n value is 1. When n equals to 1, L values are going from 0 to n minus 1. 0 to 1 minus 1, 0 to 0 means just 0. This is 0. Is this correct or not? Yes, this is correct. So, I'm just going to put the tick here. This is correct. When L value is 0, when L value is 0, how would you get ML values? Minus L through 0 plus L. 0, 0 means 0. Then, ML is 0. So, that is this correct? Is this correct? Yes, this is correct. So that this is correct. This is correct. This is either. Doesn't matter. So this set of quantum numbers are correct. If something is like you cannot admit that whether it is there or not, like you can go on check. Is it like when n equals to 2, is it okay to have n equals to minus 1? Is it okay to have ml value from this minus 1? If all are correct, put a tick here. Is it okay if you have 3, n value is 3, then L value become 2? Is it okay when L value become 2, ml to become minus 1? If all are correct, put a tick here. Otherwise, put a cross here. Clear that? Okay, do this. Copy the first one. Copy down the first one. Do the rest of the 4. Put a cross or tick. I don't know online kids how you have taken this one. I know this is really challenging part. So focus really well. Done. Raise your hand if you're done. Wow. Well done. Well done. Make sure the answers are correct. දැම්මට කියන්න සමහරක් අය කියනවා නේද මගේ chemistry too fast කියලා. මම speed up වැඩි කියනවා නේද සමහරු? ඇයි එහෙම කියන්නේ කියලා අහන්න එකලංගේ. Read that. Okay. Can I start? Everyone, look at here. Look at here. I know now you guys don't want my explanation, but still I'm giving my explanation. Finish. Okay, see. Okay. So you are going one by one. Still the same method. You have only 4 main quantum numbers: principal, azimuthal, sub-energy level, ml, magnetic, atomic orbitals, and ms is nothing. So that again, n value, if you know the n value, from n value you are getting L value. How? 0 to n minus 1. From L value you are getting ml value. How? Minus L through 0 plus L. And then ms is always plus half and minus half, exactly same. Online kids focus well, okay? Then I'm moving to the very first one. N equals to 1. And then from this n, I'm going to get L values 0 to n minus 1, 0 to 1 minus 1, 0 to 0. So that just 0. So this 0 is correct. Then from L value to ml, 0 to 0, 0, minus L through 0 plus L. 0, 0 and 0, it's again 0. So this is correct. So this one is correct. Moving to the second one, here, n value is 2. N value equals to 2. Then your L value goes from 0, 0 to 2 minus 1. 0 to 1. So values are 0 and 1. How come you have only 0 and 1, but this is showing minus 1? So minus 1 is not possible. That's why this is wrong. Minus 1 is not possible. So that this is wrong. Understood? Moving to the third one. So I'm not going to go forward as long as I know that is wrong. N equals to 3. N equals to 3. L value goes from 0 to n minus 1. 0 to 3 minus 1. 0 to 2. 0, 1 and 2. Yes, we have this. So far it's correct. 2 is here. 2 is here. That 2 is here. So that this is correct. So far correct. Then from L equals to 2, I'm going to move on to ml. ml goes from minus L through 0 plus L. Minus 2 through 0 plus 2 become minus 2 minus 1, 0 plus 1 plus 2. We have minus 2 here. Is it possible? Yes. See, the minus 2 is here. Minus 2 is here. Minus 2 is possible. This is, we don't care. So again, this is correct. This is correct. So that this is correct. N equals to 4. Then L value goes from 0 to 4 minus 1. 0 to 3. 0, 1, 2 and 3. Do we have any of those? Yes. We have 1 here. 1 here. 1 is there. So this is correct. So this is correct. Okay, let's say, then, if this is 1, how do you get ml? Minus L through 0 plus L minus 1 through 0 plus 1. Okay, do we have any of those? Yeah, we have plus 1 and it is here. So that this plus 1 is correct. We don't worry about ms values. So that this is plus 1 correct, plus 1 correct. So this is again correct. Moving to the last one here. N value is 3. Then from n values, I'm going to get L values through 0 to n minus 1, 0 to 3 minus 1, 0 to 2, 0, 1, 2. These are the 3 values. Is it possible? Yeah. We have 1 here. And that's possible. So far, this is correct. So far, this is correct. Moving on. And then, if this is the L value, how would you get ml value? From L value to ml minus L through 0 plus L. From 1 minus 1 through 0 plus 1. So values are minus 1, 0 plus 1. Only these 3 are the possible values. Do we have them? No, we have plus 2. It's not here. Plus 2 is not here. So that this is wrong. This is incorrect. See, here I have written no negative values for L. So this is wrong. L equals to 1. ml goes from minus L to 0 plus L, minus 1, 0 plus 1. So plus 2 for ml is not possible. So that this is incorrect. Clear that? Okay, mention these 2 points why these are incorrect. Mention these 2 reasons. Mention these reasons why 2 and 5 are incorrect. Now you know quantum numbers are challenging. Now you know that. Next week, let's do a couple of these tutored questions. Then you guys are gonna be better. Finish. Online kids, I don't know how you guys feel because inside the class we had like a lot of these, the practice, arguments, discussions and everything. So make sure whenever I'm asking you guys to come to the classes physically, only if it is possible. Just try to get to the class physically. Can I move on? All right. Question number 6. Look at here, look at here. Question number 6 again. State the maximum number of electrons exist in an atom for given quantum numbers. Clear? So, I'm going to go with the very first one. They are asking how many maximum number of electrons are there when n equals to 2. When we know the n value, how would you calculate total number of electrons? Tell me. 2n squared. What is the page number? I want check your note. Go back and forth. 52. Page number 52. Go there and check. When you know the n value, what is the total number of electrons? 2n squared. And then 2n squared become 2 into this 2 become 2 here. 2 to the power 2 multiply 2 equals to 8. But, so this is the total number of electrons. Total number of electrons are 8. Out of that, they are only asking ms equals plus half. Okay, out of this 8, how many are plus half and how many are minus half? Always half. One half is plus half, the other half is minus half. So that they are asking plus half, regardless minus half or plus half. Then you can divide this value by 2, this value by 2, then the answer is 4. Understood? Clear that? Don't write anything, just listen. You're going to do the rest of everything by yourself. Okay, so that is the first method. That is the first method. Maximum number of electrons here. Maximum number of electron is 2n squared. 2 into 2 to the power 2, that is 8. But only plus half is 4. Or otherwise, see, I want you guys to improve your memory and logical thinking, so that we are doing the doing the second method as well. This is for practice. N equals to 2. How would you get L values? 0 to n minus 1. Then what are the values? 0 to 2 minus 1. So values are 1, 0 and 1. Those are these two. Okay. Then when L equals to, if you know the L value, how would you find ML value? ML value goes from minus L through 0 plus L. And then for this 0, how many ML values? Only 0, only 0. And then for this 1, how many ML values? Minus 1, 0, plus 1. So these 3. Clear that? If you know ML, how do you get MS? Always each of these orbitals are having 2 electrons. What are the spinning? Plus half, minus half. So I'm going to get each of these. Each of these I'm going to get as plus half, minus half. See? Each of these plus half, minus half. Then I have to get only these plus half. How many plus halves? 4. So the answer is 4. Logical explanation of 2n squared is this. Understood? I want you guys to copy this one and then do the second one. Copy this. Try to understand, get it slowly, and then copy this, and then do the next one. I'm coming to you guys. If you have any question, just ask me. Raise your hand if you want any explanation. Any question? You guys know every week I'm doing this revision as well once we done the class. Today even I'm going to do the revision and posting it to the channel. Go through that as well. Once you've done that, try to do the next question. Number 2. Once you've done the first one, go with the second one. Okay, if you guys are done this one, I'm going to the second one. දෙවෙනි එකේ methods දෙකක් තියෙනවානේ, different methods තියෙනවානේ. මේ බලන්න. මේ බලන්න. අර last method එකේ ගිය විදිහම මේකෙත් ගිහින් තියෙන්නේ. If L equals to 4, n equals to 4, L values are going from 0 to n minus 1, 0 to n minus 1, 0 to 4 minus 1, so that's 0, 1, 2, 3. And then mn are going from minus L through 0 to plus L. So if these are L values, this is 0, minus L through 0 plus L, minus 2 to plus 2, minus 3 to plus 3, and then they are asking this thingy. They are asking mn plus 1. You have 1, 2, 3. Each mn has two ms values, plus 1 and minus, plus half and minus half. So the total number of electron equals to 6. මේකේ මම number 2 දෙකක් දාලා තියෙනවා පොඩි printing එකක් මොකක්ද මම සරලව මේකේ 2 දෙකක් තියෙනවා ඕනේ නැහැ නේද 2 දෙකක් ඕනේ නැහැ කොහොමද ගන්නකො answers පානේ තියෙන්නේ third one එකට answer කීයද 10 number හදුසන් fourth එකට 1 number හදුසන් fifth එකට මේ දැන් මෙහෙම කරගෙන ඉන්න මේ අත උස්සලා අනිත් එකේ එකයි කියලා I was like 6 නේ ඇවිත් තියෙන්නේ answer is wrong. So yeah, last one is also 1. Well done. Well done. ඔන්න බලන්න කට්ටියක් ටක් ගාලා අල්ලගෙන අනිත් කට්ටිය අපි පොඩි try එකක යමු. Copy this one and then try the third one. Anyone who need my support? Just raise your hand if I want you to get there. ඉන්න මම එනවා. කියන්න මට මොනවද ආව කියලා. Just let me know. Did you attend your thing? Sorry? Is there any questions? Really comfortable. Have you ever? What is L equals to 2? L equals to 2 means what is the orbital? L equals to 2 නම් orbital එක මොකද්ද? D නේ. D sub energy වලට orbitals කීයක් තියෙනවද? 5යි නේ. එතන 5 ඉලෙක්ට්‍රෝන කීයක් තියෙනවද? 10යි නේ. ඕක තමයි බෑක් යනවද සප්රේට් යනවද? සප්රේට් යන්නේ. It is taking like 1 second. Right? Why metals කොච්චර තියෙනවද කියලා? Any question about it? Finish. Keep it up. Yes, I can. What do you think? සුසුලට නෝකියද? ඊළඟ සපෝට් කරනවා. හා උදාහරණයක් යන්න දෙන්න. උදාහරණයක් දැන් ඔරුත් ටික කියනවා. වෙනොන් දෙන්න කන්දේ එතන කිව්වා මේක ආයෙත් ඉස්සලා රෙකෝඩින් එක කරනවා. අනිත් පැත්තට දැන් පිටන්න ආයෙත් එක්සෙප් එකේ. ආයෙත් හරියට මාරු පස්සේ කැමති ඉස්සලා කරා. ඊපස්සේ මේක අතර කරා. හරිනේ. If it is structure is and this is the ask the reduce not the thing at all. But then structure පාවිච්චි කරනවා. structure හරියට ගන්න. ඒ ඔක දෙයක් තියෙනවා. ඕල් මේක දෙන්න මම කියලා. Okay, I'm moving to the third one. And when L equals to 2, we don't have to worry about this N because here we are not worrying about the N because they were specifically saying L equals to 2. N equals to 3 වෙන ඔක්කොම ගන්න බෑ. Out of that L equals to 2, if L equals to 2, number of electrons are 2 into 2L plus 1, that is 10. Or otherwise, if L equals to 2, Mn goes from minus L to plus L, minus 2 to plus 2. So each of these are having 2 electrons. So altogether it's 10. Yeah, to 0, ml is definitely 0. 2 electrons, but they are only asking minus half, so it is just a one single electron. Or otherwise, L equals to 0 mean maximum number of electrons supposed to be 2 into 12 plus 1, that is 2. Out of that, they are only asking minus half, so that is only 1. Or otherwise, you can just go very easily. L equals to 0 mean S orbital has only 2 electrons. Out of that, only minus half is one single electron. There are 3 different methods to get this one. Okay, copy these two. Having all four quantum numbers for a single electron is characteristic for that electron. So X is only 1. So it is exactly 1. You can write that, or otherwise, let's do that next day. Let's start from here. That part, that answer, I can show it now here. So there are a couple of methods to get that answer. That's why we don't have time for that. Let's do this on next day. Hang in everyone. Just listen for a second. Okay, now you guys know how challenging the quantum numbers are. Now you guys know how challenging the quantum numbers are. Then what are you supposed to do? Listen here, everybody. Quantum numbers are really challenging. Next day, I'm going to pose a couple of these questions to the group from the tute. So complete those questions ahead of time before you get to the class. Let's discuss those questions at the class because these quantum numbers are, I don't know whether I have already මේකේ තියෙන මම දාන්න. අමේදී මෙතන එකයි තියෙන්නේ. මේ question number 77. Question number 77 you're going to do quantum